Hello and welcome. We're here to learn about several evidence-based learning strategies that can really impact student learning. Now, these strategies don't have anything specifically to do with technology, but the point of this is if you use these strategies with technology, you're going to get a better bang for your buck when you have technology. Make sense? Let's carry on. All right, so we've got 7 learning strategies we're going to cover today. This isn't all of it. It comes from the world of cognitive science, but these are ones that are really have decades, in some cases over a century of research. They're flexible. They work across all grade levels, subject areas, age groups, ability levels. They don't require a tremendous amount of expertise. It's really hard to screw these up. Okay, some of the pedagogical practices you learn about, you got to do it just right to get the learning gains, not with this stuff. So, sound too good to be true? Well, it's fantastic. So, I know you're a great teacher already, and I'm hoping that these strategies will help you become an even better teacher. All right, let's dive in. The first one is retrieval practice. Now, essentially what retrieval practice is, the act of recall. And the idea is trying to remember something actually helps you learn it, okay? Trying to just recall something you have learned actually deepens your understanding and your long-term memory, okay? The metaphor here, and you can see it in the image, is trying to pull information out instead of cramming it into your brain, okay? All right, so we're going to spend some time on retrieval practice because it really is foundational to many of the other 7 that we'll talk about. So again, it's an active process. Actively trying to recall what we've learned makes the learning deeper and more durable. Okay, it works with concepts, it works with skills, it works with information and facts learned, pretty much any type of learning. All right. There's a notion of desirable difficulties. Okay, the more challenging the recall activity is, the longer you'll retain it in your mind. And that's something that most students don't feel intuitively. They feel like if something is easy as they learn it, it's going to, that they understand it and know it, like rereading something or highlighting. Not the case. Really struggling to recall something's on the tip of your tongue, you're trying to pull it out of your mind. Aha, I remember it. That is better. So a good metaphor is exercise is good for your body. That struggle to recall is good for your learning. Okay. All right. It can quizzes, flashcards, writing, speaking, many types of activities you can do with retrieval practice, okay? Anything, it feels sort of like assessment, but it's actually what we're talking about here. This is not an assessment strategy, okay? This is a learning strategy. And while some of it will feel like assessment, like quizzes or written, writing down answers on things, flashcards, stuff like that, it doesn't have to be for grades, okay? Just the act of doing those things helps deepen the learning and the retention of that learning, okay? So the advice is make it low stakes in terms of marks, very low or no stakes at all. Now you want to know an added bonus to doing retrieval practice regularly with your kids? That is that what they found is when you do regular quizzing activities with your kids, it actually lowers their test anxiety when it comes to high stakes exams, okay? Because doing quizzing and those types of recall activities, challenging mental activities, isn't only done in a really high stakes situation. It's just everyday business so that when the bigger test comes, they'll associate it with more positive feelings. All right, so there's another added bonus, and that's retrieval practice. Lots of ways you can implement this in your classroom. A couple of ways we will talk about as far as technology go have to do with digital quizzing, digital flashcards, or even written responses, things like they call a brain dump, where write down everything you know about a particular thing or what we learned about yesterday in our science class, and just having them write and write and write until they can't remember anymore. That can be done digitally, it can be done on paper, it doesn't really matter. But as we think about technology and doing quizzing, I'll show you a great quiz tool here shortly. But when it comes to quizzing, again, make them low stakes or even no stakes at all. They don't have to be for marks. In fact, you don't even always have to look at the quiz answers, as long as there's a way for students to know. For example, self-grading digital quizzes. Okay. Again, when the research talks about short answer versus multiple choice, it doesn't really matter. Both are effective. The paper versus digital, again, there's no distinct advantage to either. They both have some advantages, but in terms of learning benefits, learning gains, not really. So it's just take your pick. But certainly there are some great digital options. And here's one great digital tool you can consider. This is one tool that I really like. It's called quizzes.com, Quizzizz.com. Now, if you get enough teachers in your school, 5, to register for quizzes.com, you get all the premium features free forever. You heard me correctly. So I'm not here to sell you a product. Some of the premium features do cost if you have less than 5 teachers in your school subscribed. But regardless of that, we'll look at just some free features here. They've got an extensive library, so anything you want to search from, you can type in or do a search. They've got literally millions and millions of these quizzes in here, and I kid you not, there are hundreds and hundreds and hundreds of thousands on every topic that you can imagine. And you can also create your own quizzes. There's even a feature now called Quizzes AI, where that is in the sort of premium version, which if you've got 5 teachers or more, you'll get that for free. Otherwise, it's a paid feature. Here's that Quizzes AI. It can generate it for you. Regardless, there are lots of ways to get these quiz features. I'll show you one example. Hey, look at that. We've even got one for these 7 learning strategies through cognitive science. So when you have your quiz created, you can assign it to students, and it can be assigned as a live thing. You can play it now live with your students, kind of like you would with Kahoot, or you can assign it as homework, and that would be something that students could do even in class or at home. They can do self-paced, which is really nice. And there's a whole bunch of accommodations that are built into this, learning accommodations that students can pick from when they're doing these quizzes. You can even download it as a physical worksheet if you needed that. You can collaborate with others. You can, instead of having it as a quiz, you can have it as flashcards instead. Okay, I'll give you a tiny little preview of what it looks like for the students to play. Okay, there are different things you can select. There's even a text-to-speech if it's needed. Flashcard option, as I said. And I'll just show you one question here. So here are the digital quiz questions, and you can, there you go, right? So that is just going to stop that at that point. So it's very easy to play. You as a teacher can get some great analytics on this from your students that play, but very easy. If you want to assign it to students, there's a great feature there as well, where you can give them multiple chances at it, and lots of great features to help students do it on their own time. Great activity for them to do with their parents at home, works on any device, and really helps solidify that learning. All right, we're on to our second learning strategy, and that is called spacing. Another name for spacing is spaced retrieval practice. So you remember what retrieval practice is, right? Recalling things to mind. So the idea here is that the longer you can go over time and still recall something, the longer you will remember it into the future, okay? And And the greater that struggle is to remember, and if you can successfully do it, the longer it will sort of stick in your brain. Okay. Consider the opposite of spacing is cramming. So the night before you cram, you really study hard for something. The next day you can do okay, but over time you're not going to do great. When you space out your retrieval practice, not doing more of the studying or retrieval practice, it's spacing it out over time. You will retain it for far, far longer. Okay, this is based on the forgetting curve by a guy named Ebbinghaus. Now you can see here on this graph that when you first learn something, you immediately start to forget it. And in fact, within the first couple of days, unless you actively process it and try to recall it again, you're going to lose a good portion. I think it's 80% within the first day you're going to lose. It says here you'll retain up to 80% after one day, but I've heard otherwise, where you will lose most of it after one single day. So what you try to do by recalling that information or the knowledge, the skills, the concepts, is that as you're starting to forget, you recall, it brings your memory up again. And then the forgetting curve kind of flattens out over time. And instead of forgetting something quickly, it will take a long, long time. And then see if you can go for longer periods of time, a couple of days before you have to review it to remember it again, or even longer. Okay? And that's the idea behind spacing. One way you can do this with technology, there are many ways, but one is through something like this. It's called a retrieval practice challenge grid. We're going to do one as your participation task. Okay? And essentially what it is you can create some quiz questions on this grid and color code them based on how recently you learned about them. And if you want to make a fun game of it for students where they can challenge themselves to beat their own high score, you can make the ones that you learned a lot longer ago, 2 weeks ago, 3 weeks ago, last unit, last month. You can make those worth a higher point value. So essentially, students with a list of questions on a grid like this can challenge themselves at any time and see what they can get for their high score and see if they can beat it over time. Now, creating this in something like a slides presentation like PowerPoint or Google Slides is really great because in a month or so, you can just duplicate the slide, change out some of the questions, and now the things that you just learned are now things you learned a month ago, and you can add in some new content without having to start over again. And even sharing that entire slide deck with students can be really quite helpful. So just remember that with space retrieval practice, you're trying to space it out over time to sort of interrupt that forgetting curves. Because if you can do that, the longer you can go and still remember something, the longer it will stay in your mind more permanently, and greater understanding as well. Okay, interleaving is our third learning strategy. Now with interleaving, what we're talking about is switching up retrieval practice content, okay, between similar but slightly different concepts or skills or information, and it forces the learner to distinguish between multiple things. Here's the opposite of interleaving, is blocked practice. Do you remember in math as a kid, you were learning how to do a new mathematical algorithm or steps, let's say 3-digit plus 3-digit addition, and you would get a whole bunch of those questions in a row, and you would just burn through them and just kind of the whole notion, the metaphor was burning it into your memory. It's not really a thing. What happens when you do too much blocked practice is that it's not going into your long-term memory. It's only staying in your active working memory. You're not having to recall it because it's still right there. So if you can switch up the content a little bit, you switch up some addition with a little bit of subtraction. You switch up a little bit of this science content you learned here with a little bit you learned in last unit or a previous lesson or a week or what have you. When you mix it up like that and switch it up, it forces you to dig into your long-term memory each time. And remember, every time you do that, it gets deeper and deeper ingrained into your mind. But it doesn't happen through too much block practice. Now, understanding, and when it comes to math, sometimes you do need a few practice questions to sort of get the hang and see the sort of the patterns that are involved in the skill. Okay, but don't rely on that solely. As soon as you can, get into interleaving and mix them up for kids. It's going to be harder for kids, and let me tell you, it's not going to be fun for kids in that sense. This is more challenging learning, and this is a great time for me to point out, with these learning strategies, get the kids involved in knowing what you're doing. Tell them why you're doing these types of retrieval practice activities, spacing, interleaving, and the other ones we're going to talk about. Explain that it's going to be challenging, but you're making them a better, more stronger learner who knows more and can do more and be more powerful as a learner. And just like exercise, it can be quite challenging, but totally worth it. And that they have it inside them. They're going to find it the most challenging when you start off doing these types of things. But over time, they'll start to embrace it and enjoy the challenge. Just like we do when we start to work out. You know, it's sore, we don't want to go. And then after a while, you get into the habit, you feel more confident about yourself. Found very similar things. I've talked to lots of teachers who've done these things with kids, and that's what they've found. So just get over that initial hurdle. And at an age-appropriate level, try to get them in the game and explain to them, and maybe even their parents, what you're doing with these learning strategies and why you're doing it. Why is it so challenging? Okay, so for interleaving again, here's a couple of visuals, right? It's switching between ideas when practicing. And then you can even go back over the ideas in a different order. And again, it will feel harder, but it will, at the end, it will make you a stronger learner, and you'll have a greater prize at the end. Some of these visuals are from a really great website called the learningscientists.org. learningscientists.org. Not that at the beginning, but anyhow, great website. Lots of great stuff on this cognitive science. All right. We're going to move on to the fourth learning strategy. This one is least like an actual learning strategy and more just a good practice. What it is called feedback-driven metacognition. And essentially it's this. Here's the thing. What students think they know and think they don't know is often very different from what they actually know and actually don't know. And there's a lot of reasons why students will have false confidence or a false lack of confidence. Remember, some of the challenging learning experiences through retrieval practice and interleaving, spacing, etc. I talked about, that can be very powerful to help students learn a lot more than they think they are. But it feels hard, so they might think they don't know it that well. Conversely, if they're just rereading a page or notes or just rereading a chapter or something like that, they feel confident. It feels easy. They feel overconfident when they don't actually know the content, know the skills, know the concepts as much as they think they do. So that's where feedback comes in. When we can provide feedback to students, and that can be done through a lot of different ways, on where they're actually at with something right away, that can really help correct those misunderstandings and get them back on track with learning. Okay? That can be done with technology in a couple of different ways. The top little graphic here refers to, on tools like quizzes.com, it will often self-grade those quizzes so that students can see immediately, oh, I thought I knew that one, I guess I didn't. Or flashcards, or I give some pretty immediate feedback. You look on the other side of the flashcard. Remember, with flashcards, though, you must challenge yourself to try to recall first. If you just look at the question, then flip it over and look at the back, it's not doing anything good for you. The second graphic there is from Screencastify. It's a web-based screen recording tool. I'll be using it in this course. And that's another great way to give students feedback on their digital work. You got something up in Google Docs or Slides or whatever it is, right through your browser, very quickly you can give your verbal feedback. They can see you if you want to turn on your webcam. They can hear you, and you can explain to them where they're at in their learning. It can be very quick, probably faster than you writing it down or even typing it down. And so it can be a very efficient way, as well as a very effective way to correct them on their misunderstandings. So that is feedback-driven metacognition. Number 5, we're getting through this, everybody. Number 5, this is an awesome one. And again, some of these may seem captain obvious, and this one is probably one of them. Okay, some of the others actually are not that captain obvious, right? The challenging yourself to learn, like the spacing and interleaving, don't actually feel intuitive, right? Mixing up your retrieval practice instead of block practice feels pretty natural and right. Don't get too sucked into it because it's not. This one, though, right on the money. Here's what it is. When you can really elaborate on your ideas and explain a great deal, every time you try to explain something in great detail, your learning and understanding and your memory of it will become better and better and better every single time. So elaborative interrogation sounds pretty nasty, but it's actually pretty awesome. That involves asking how and why questions, and then answering with great detail. So instead of giving students just facts about, let's say, how an airplane wing, how something flies in the air, you can ask them, how does an airplane lift off the ground? Why is the top of a wing on an airplane curved and the bottom flat? Why is that? How does that make an airplane lift off the ground? So those types of things, and having them answer in great detail. What they're doing is they're digging into their long-term memory, and they're attaching on to things they already know, their background knowledge, and sense making in the moment, and building it onto something new. Very effective, and it goes into that long-term memory, and also forces students to really understand what they're saying instead of just rote memorization where they're not. Okay. Memory gets a bad rap sometimes, but it's actually very effective, very vital in the learning process. But we don't just want people to remember something without understanding it, of course. Okay. How and why questions, once again. One way you can get students to do this, elaborate in great detail, recording their voice, recording their screen. There are tools like Screencastify. There are screen recorders built into Chromebooks and things like that. If students have Chromebooks or iPads, things like that. There are lots of ways that students can record themselves elaborating on something in great detail. You can also take video of students. Be careful on that one with a privacy standpoint, talking to the parents and making sure everybody's aware and on board with that method. You wouldn't share that outside of your classroom, and you would delete those videos when you no longer need them for assessment purposes. Anyhow, having students just elaborate greatly. All of the platforms, Chromebooks, Windows, Mac, tablets, smartphone, they all have built-in screen recording capabilities. Okay, it can be an effective, certainly not the only way for students to elaborate. They can turn and talk to someone. They can turn and talk to you. Lots of ways to elaborate on your learning through those how and why questions. So that is elaborative interrogation. We've got 2 more to go, everybody. Number 6, concrete examples. This one is super captain obvious. Concrete real-world examples to help understand complex concepts is a very effective way to remember and understand something. Okay, they can connect that new concept to something in their mind that they, to something they already do understand. Okay, I may not understand the circulatory system and all the major arteries and capillaries and really tiny little, blood vessels in my body. However, I do understand highways and major highways versus secondary highways versus small little paths and individual paths that a person walks on, and understand and make that connection between, our roadway system and the circulatory system. All right. So it takes something abstract that they really can't connect to and connect it to something in their long-term memory that they do really know and understand. All right. And our final one, before we go on, this is probably the most famous, am I right? Fractions, pizza. We've seen that example over time, a long time. So there are lots of digital images you can bring in, videos you can bring in, multimedia you can bring in on your technology to help students understand those complex concepts through icons or through rich images that you can bring in onto the screen as you're describing them, that are sort of a metaphor for that concrete example of what you're trying to talk about in that concept. Okay. And the final one, dual coding. This one is also super Captain Obvious, but there's a lot of really good details about it. And that's this, that if you can teach with both words and visuals, it's far more effective for learning than just with words alone. I think we would all agree on that. We've seen that over time. If you're an old dinosaur like me, we've had chalkboards and teachers would have chart paper and draw things on it and draw on the chalkboard. We had overhead projectors and now digital projectors and televisions in our classrooms where our words that we're teaching kids, our words that we're speaking, or words that they're reading are accompanied by rich visuals or multimedia. Okay. Now that seems simple, but there are a lot of really important factors that can go into that. And I'll get into those factors in a second, but here's a bit of a visual metaphor to help you understand. Okay, see, we're going to practice what we preach here. Dual coding. So essentially, our brain has a couple of different encoding mechanisms in our that as we take in stimuli from the world. There is a visual track that can, if you see an image, you can see a lot of things all at once. Okay, it can imprint on your brain many things in a rich image. Words, on the other hand, we have an audio or a verbal encoding track in our brain, and those words come in one by one by one, sequentially, right? Like a recorder of some kind. So whereas visuals come in a lot of things at once, the auditory channel is encoded in a linear fashion, one after another. All right. So what is this? And both can work at the exact same time. You got both encoders going, dual encoders, dual coding. Okay. That is going to really deeply enrich the learning. Okay. And the sum is greater. The whole is greater than the sum of its parts. Is that how the saying goes? You get what I'm saying? All right. Now here are some tips for designing effective learning slides with your students. It's really important. First of all, if you're speaking to a concept you're teaching, really avoid the heavy use of visual or words on your slides. If you're talking and students are reading, they can't connect both at once. It's like two audio tracks at once, because when you read, you're actually hearing the words in your head, right? You hear the narrator. And if you're speaking as a teacher at the same time, it's like two people are talking at once. Your brain can't do it. All right. So if you are going to be speaking to something that you're teaching, really, really drastically limit the amount of words on your screen. Okay, just a few keywords or a phrase at a time. On the other hand, as you're speaking to something, including visuals on your slides are a very effective way to do this. Both tracks, visual and verbal, can be going at the same time. Keep a consistent organization of your slides. You know why books are so effective, real books? Because they're organized in a very consistent way. We go left to right, top to bottom, we flip the page, and our eye knows exactly where to go. All right. If your slides are organized helter-skelter, it's going to confuse and distract students a bit. So try to keep your words and your images in the same relative space if you're presenting multiple slides to students. That can just help them focus on what you're trying to learn instead of wondering, where do I look next? Does that make sense? I hope so. And finally, while it is tempting to include funny animated GIFs or even tell really funny stories as we present our materials to keep it engaging, be cautious and judicious about how often you do that, because what can happen is that will be the thing that they remember. Some really funny story or really hilarious animated GIF. You have, you know, you're doing a lesson on social studies and you throw in a Ryan Reynolds Deadpool animated GIF on to try to send home the message. They're just going to remember Deadpool. So we don't want that either. So be cautious about that. And those are some tips on organizing slides to really enhance that dual coding learning strategy, okay? Now, before we leave dual coding, I wanted to address, there has been a long told but false myth about something called learning styles. I'm a visual learner. I'm an auditory learner. I'm a kinesthetic learner. I learn better through one modality than the other. And it's been disproven. It's been debunked for many years, but it's prevalent. The important thing here is as we learn things, as we adopt beliefs as professional teachers, it affects how we plan and organize our lessons. So be cautious about that. Everybody learns better with words and images together, period. You may have a preference on certain things, but the research shows that it doesn't affect your learning any differently. So those are the 7 learning strategies we've covered today: retrieval practice, spacing, interleaving, feedback-driven metacognition, concrete examples, elaborative interrogation, dual coding. I'm just going to be straight up and tell you that this is going to be one of your optional questions that you can write long answer on your final exam. And it's a pretty easy one. Understanding these 7 learning strategies, what it would be an example of how technology could assist in implementing that learning strategy, okay, in the elementary classroom. Thank you very much. I hope you enjoyed the video. It was a little long one, almost a half an hour. Sorry about that. And have a great day.